For number 14, we are given that a transformer has 550 primary turns and 13 secondary turns. For part A, we're asked if VP is 120 volts RMS, what is VS with an open circuit? If we write down what we have, we can see that we have primary turns, and the number of turns is usually marked as N, but we can have a subscript P for primary. This is going to be 550, and our secondary turns can be N of S, and that'll be 13. For A, to calculate V of S, because it's asking us what V of S is, we can use this formula. We can say that our V of S, because that's what we're solving, equal to the number of turns. And to solve this, it's going to be, normally it's just N, but we're going to have, since we have a primary and a secondary, we have our secondary on top and our primary on the bottom. Our primary number of turns has to be on the bottom, and the secondary will just be on top. Our V of P is then multiplied by this. From here we can start plugging in our values. We get that our number of secondary turns is 13 over our primary turns, which is 550, and this is all being multiplied by our V of P, which is 120 volts. From here we get that our V of S is approximately 2.84 volts, and this is the answer for part A. We have to write down our new value, which is R is equal to 15 ohms. We can use this formula to find the primary current, and that is I of P is equal to the voltage of the secondary divided by the voltage of the primary, similar to our N of S times N of P here. We can put this in parentheses because we need to multiply this by the current flowing through the secondary. We have to do this because this is the primary and it splits this between itself and the secondary. From here, we can plug in the values that we know. We don't know the secondary current, but we do know that the I is equivalent to voltage over resistance. In particular here, voltage of the secondary divided by resistance of the secondary. And we were told that the secondary now has a resistive load of 15 ohms. So this is actually our secondary. So in here, we'll have our V secondary, which we found in part A right here, to be 2.84 volts over our R secondary, which we were given as 15 ohms. If we're going to plug in all of our values, we have I primary is equal to V of S, which is again 2.84 right here, divided by V of P, which we were given right here to be 120 volts. We could put these in parentheses and then multiply what we wrote down here, which was 2.84 volts divided by 15 ohms. After we plug this into our calculator, we're just going to get approximately 0.0045 ohms. Another way we could go about solving this is using IP, so the current primary, is equal to N secondary over N primary times I secondary. This is very similar to this formula right here. The only thing that's different is we're replacing the voltages with our currents. And after we do this, we can plug in our values, so that I of P is equal to 13 over 550 times our I of S, which is 2.84 divided by 15. So we see that this answer and this answer are equivalent, meaning that either of these formulas can be used. For part C, we are asked if the secondary now has a resistive load of 15 ohms, what is the secondary value? We can rewrite that our resistance of secondary is 15 ohms, and to find the current secondary, well, we actually already wrote this out. We have our current of secondary is equal to V of S over R of S, or voltage secondary over resistance secondary. And we already put in our values. So we have I of S is just equal to 2.84 volts over 15 ohms. And if we plug this into our calculator, we're going to get that I of S is equal to approximately 0.19 amps. And that is the answer for part C.